So in today's video, we're going to go ahead and cover the chain rule for the first fundamental theorem of calculus. And so as a little bit of a review, the first fundamental theorem of calculus tells us that if we have a function right over here that we can call, capital F of x, let me just erase that because that's a very... Okay, so if we have a function that's essentially defined as the definite integral from a to x of f of t dt of some function f of t dt, where f of t is continuous over the interval a to b, right? So over this closed interval right over here, and x is a member of this closed interval, then the derivative with respect to x of this integral right over here is going to just be equal to f of x, right? So we take the integrand and we replace kind of the independent variable. We change it from t into x, basically. And of course, f is continuous, etc. And essentially, one thing that we have to mention as well is that a has to be kind of any endpoint, or it has to be the endpoint of any closed interval over which our function f of t is continuous. Doesn't really matter what it is. We looked at that in the previous video. We don't really care what a is as long as it functions as the kind of lower endpoint of a closed interval over which f is continuous. That's really, if that makes sense, that's essentially that's the only thing we really have to worry about when it comes to a. But when it comes to taking the derivative in the first fundamental theorem, we don't really care about what a is aside from that condition. And so now we're going to extend this and we're going to use the chain rule to see what happens when instead of x, we have some sort of function of x. So suppose that we have a function capital F of x that's defined as the definite integral from a to g of x. So now we're no longer keeping that as x, we're generalizing it into just g of x of f of t dt, right? Again, f is continuous, etc. And we want to find the derivative of capital F, so df by dx, or d capital F by dx, is going to be actually given this time by f of g of x times g prime of x. And if you want to think about that in terms of the chain rule, we basically just input, instead of replacing this t with an x, we input g of x, right? So we have a composite function right over there. And then we multiply that by the derivative of g of x. And that just comes directly from the chain rule. We may eventually delve into proofs for the first fundamental theorem and this extension with the chain rule. But that's a little bit outside of the scope of the video right now. And so let's go ahead and actually apply this rule. So here we have a function capital F of x, right? And it's defined by this integral right over here in terms of t. And essentially what we're going to do is we're going to try to find f prime of x, or capital F prime of x. And so the definite integrals, the bounds of integration are from pi to 4x squared plus 1, and their integrand is the square root of t minus 1 dt. So let's go ahead and actually use, first of all, the first fundamental theorem, and then we're going to apply the chain rule as well. So the first fundamental theorem tells us that essentially we just have to take this integrand and replace t with this kind of g of x right over here, right? So this is our g of x right over here. And so capital F prime of x is going to be the square root of, instead of t, we're going to input g of x. So this is what, g of x minus 1. And then we're going to multiply that by g prime of x. So let's actually now go ahead and start replacing different things. So g of x is 4x squared plus 1. This is going to be 4x squared plus 1 minus 1, right? And then we're going to multiply that by g prime of x. And we know that the derivative of 4x squared plus 1 is just going to be 8x, if you remember that from our differential calculus playlist. And then let's go ahead and just do some simplification over here. This 1 and negative 1 will cancel. And then the square root of 4x squared is just going to be 2x times 8x, right? And so this is ultimately going to end up being 16x squared. And that would be our final answer. That is capital F prime of x, or df, or d capital F by dx. So that would be our final answer. See, it's very easy to actually use the chain rule. It's not that complicated. It may seem a bit scary when it's in this very abstract form, but when you apply it, it's actually not that bad. And so let's go ahead and evaluate this, or take a look at this problem over here. So we have capital G of x. It's defined by this integral right over here, where the bounds of integration are pi over 2 and sine of 3x. And so now we can kind of define this as our lowercase g of x, right, as our bound of integration function. And we want to find capital G prime of 0. So the first thing to do is obviously to find what G prime of x is in general, or capital G prime of x. And we know we're just going to take this integrand right over here, replace the t with g of x. So it's going to be g of x squared plus 7, right? And then we're going to multiply all of this by the derivative of g of x, so or derivative of lowercase g of x, so lowercase g prime of x. And that's going to be equal to, it's going to be sine squared of 3x plus 7. And then we're going to multiply that by the derivative of sine of 3x, which is, if you recall, that's going to be 3 cosine 3x. Again, this just comes from the chain rule. And then what we're going to do is we're just going to replace x with 0, right? And so this is going to be equal to, let me actually move all of this down so we have a little bit more space, right? So let's just move this over here. And so what we're going to do is we're going to go ahead and put x equals to 0. So we'll end up with sine squared of 3 times 0, which is just 0, plus 7. We're going to multiply that by 3 cosine of 3 times 0, which is also going to be 0. And so we know that sine of 0 is 0, and so sine squared of 0 is also going to be 0. We know that cosine of 0 is 1, right? And so we just end up with 7 times 3 times 1, which is just going to be 21. And so that would be g prime of 0 right over there. So as you can see, it's actually very easy to apply this rule. You just have to identify what your upper bound function is, and then basically just use the fundamental theorem of calculus and kind of connect it with the chain rule to end up with this result.